So the lecture 31 is about software costing, and the software cost estimation involves the predicting the resources required for software development process. The fundamental estimation question is that how much effort is required for complete the activity, how much calendar time is needed to complete the activity, what is the total cost of the activity, and the project estimation and scheduling for the interleaved management activities. It's just like trying to estimate the whole cost, the time cost, the efforts, and the estimation. Yeah, it's just like estimation and estimation and scheduling and interleaved management. It's just like trying to involve the management staff with the process development. And the software cost component is that maybe like the hardware and software cost, the travel and training cost, the effort cost, and the effort cost is the dominating factor of the almost projects, and maybe like the salaries of engineering and the social and insurance cost. Finally, we also have the cost efforts must take overhead to account. That's just like the cost of the building, the heating, and the networking and communication, and the kind of the shared facilities like a library and restaurants. So everybody have a price, right? The cost in pricing is that trying to estimates are made to discover the cost and to the developer of producing a software system. There's no simple relationship between the development cost and the price charged of the customer, and the broader organizational, economical, and political business considerations may influence the price charge. So, for example, we have the software pricing factors, like the market opportunities, just like and the cost estimate uncertainty, the constructual terms. This one is not very sure. I'm going to make sure. The constructual terms and the requirement volatility, the financial health, the market opportunities. That's just like how much it was on the market. The cost estimation is a range, yes, and of the cost and the constraint and the constructual term is just like the customer may need willing to allow the developers to retain the ownership of the source code, and if the requirement variability, that if the requirements are likely to change, an organization may lower its price to win the contract. And the financial health is just that the developers in the financial difficulties may lower the price. Yeah, all these kind of things is change your price, okay? And apart from that, we also have some programmer productivities, which is a measure of the rate which the people may produce software documentation. And it is not quite quality orientated, but throughout the quality assurance is a factor of productivity assessment. So essentially, we want to make sure the useful functionality produced per time unit, and the productivity measures is just like the productivity measures is a size-related measure based on some of the output of the software process. For example, we have the line of code, the number of classes, and the function-related measures based on the estimate of functionality of delivered software. Yes, it's just like function points. Yeah, there are two ways to measure the productivity. It's like how many lines, how many classes. And second one is function-related. Yeah. So the measurement problem is just like we're estimating the size of the measure and estimating the total number of program months that will have elapsed. we're going to estimating the contract productivity, select the documentation team and the incorporation, and incorporating this estimate to the overall estimate. So in order to do that, we're going to use some indexing systems such as line of code. For example, the line of code is just a measure of the first proposal when the program is typed on the card, per line per card. And how does it correspond to the statement that Java, maybe several line code, where there is maybe several statements in one line. And so the program should be counted as a part of the system. And what program should be counted as a part of the system? Assuming the linear relationship between the system size and the volume documentation. So the productivity comparison is that the lower level the language, the more productive the programmer. The lower level, Why? The same functionality requires more code to implement to a lower level language than a higher level language. And the functional point is that based on the combination of the program characteristics, we have the external input and output, the user interface, user interactions, the external interfaces, the file used in the system, and the weight is associated with each of these, and the function points counts is computed by multiplying each row count by the weight and summing all these values. The function point is based on the combination of program characteristics, and the weight is associated with the functional point is computed by multiplying each row count by the weight of the. This is not true. I'm going to make sure. Okay. And the object point is the an alternative function related measure to measure functions, and the object points are not the same as the object classes. The number of object points in a program are a weighted estimate of the number of separate screens that are displayed, the number of reports that are produced in the system, the number of modules that must develop. And the productivity estimate is just like for example, for a real-time embedded system, is like 30 to 106 per person per month. And system program just like 150 to 400 line of codes per person per month. And the commercial application at 2,000 and to 1,800 of codes per person per month. And in the object points, the productivity has been measured between 4 and 50 objects points month, depending on the type of applications, the tool support, and the developer capacity. So the factor influencing the productivity, just like the application, domain experiences, the process quality, the project size, the technology support, the working environment. So for example, the factor that the application domain experiences, just like the knowledge of the applicant's domain, is essential for effectively software developers and engineers who already understand the domain. Is more like to be most productive, and the process quality is that the development process is used to have significant effect on the productivity. And the project size is the larger the project is, the more time required for a team to communicate. And the technical support is just like what if you are using the latest version of MATLAB, it will be much better than the original version. Since and the working environment is just like the working environment contributes to the good design. And apart from that, we have the quality and productivity. It is argued that all matrices based on the volume and the unit time are flawed because there's no quality taken into considered, and productivity may generally be increased at the cost of the quality. It is not clear that how the productivity qualities are matrices are related. The matrix is here is just like the relationship between each other. Yeah, it's just a measuring system, and if change is constant, for example, simplifying and improving code, for example, then an approach based on counting lines of code is not meaningful. So, for example, we also have the estimation of the techniques. There is no simple way to make an accurate estimate of the efforts required to develop the software system. And the project estimates may be self-fulfilling. It's just like there's no the initial estimates are based on the inadequate information of the user requirement identification. The software may run on non-familiar computers with new technology, and the people in the project may be unknown. Yeah, just it's very hard to do so, and we are going to use the following techniques. So, for example, the first one is called algorithmic cost modeling, the expert judgment, and the third one called estimation by analogy, the Parkinson's law, and the price to win. So the algorithmic code of modeling is called is a formulaic based approach based on historical cost and of information, which is generally based on the size of software. And the algorithmic code modeling is like the efforts is going to be the organization dependent factor times the size to the power of the disproportional rate efforts for large disproportionate factor for a large product, and M is the multiplier reflected in the product. So the most commonly used product attributes is the code size, and the most models are based similar with different values A, B, and M. And expert judgment is just you tell your friend that they are going to do that. How much effort do you think you need? The advantages are relatively cheap, but the disadvantage is not very accurate. And the experiment-based estimate is estimating is primarily experience-based, and however, new methods and technologies may make estimating based on the experiment inaccurate. For example, the object-oriented rather than the function-oriented, and the client-server system rather than the mainframe system, and off-the-shelf components based on software engineering. And case 2, the programming generators. The off-the-shelf component is just the something. It is originally there, but we are going to make some adjustments before implementing that here. Therefore, this kind of effort is called off the shelf. Estimation by analogy is that the cost of product is computed by comparing the product with similar products. For example, it is accurate if the product data is available, and there's some disadvantages. For example, it is impossible if there's no comparable objects that have been tackled. Needs systematically maintain the cost database. And the Parkinson's law is just like you are going to take everything you need for Let me illustrate the Parkinson's law here. The Parkinson's law is just like the Parkinson's law is that the time available and the time to take is going to approximate that, but the time to win is that the cost estimate and the cost needed is the cost is limited, but we are going to approximate this cost through taking the outsider approaching to the insider. So that's the main difference. And the Parkinson's law is that the time to consume is going to take as much as possible available time, and the pricing to win is just like trying to就你给我多少钱，我给你办多少事儿啊。And this is kind of like unethical and unbusinesslike. However, the detailed information is lacking, maybe the only appropriate strategy, and the project cost is agreed on the basis of the outlined proposal, and the development is constrained by the cost. A detailed specification may be negotiated by the evolutionary approach based on system development. So apart from that, we also have to consider some top-down and bottom-up estimation. Is that any of these approaches may be used by the bottom-up and top-down. And the top-down is that start with the system level and assess the overall system functionality and how it is delivered throughout the subsystem. The bottom-up is start at the component level and estimate the effort required for each component, and add these efforts to reach a final estimate. The estimation method is just like each method has the strength and weakness. The estimation should be based on several methods. If this does not return the approximately same result, there is insufficient information available. Some action should be taken to find out more in order to make more accurate estimates, and the price to win is possibly the most easiest one. And the size of software system may be known accurately when it is finished, and the development process is become more accurate. Thank you very much for your support, welcome comments, subscriptions.